5.4 is solving rational, so keyword here we know, rational equations. So there are two things here. When you know it's an equation, you know you're going to get regular just kind of numbers as an answer, not a domain, not infinite number of answers. So there's going to be a solution for your equation. When we talk about, and so if you're like, what's the opposite of that? The opposite or not opposite of that would be an inequality. So 5.5, we're going to look at inequalities, which is the greater than or less than. So there's going to be ranges of answers, like x is going to be between 2 and 4, between 7 and infinity, stuff like that. So an inequality is going to give us a range of answers, right, infinite answers here, and an equation will give us answers, right? So x equals 2, x equals -3, x equals 5/4, stuff like that, so an equation. So knowing that, when we're solving, we have a rational equation. We're going to solve it. The way that I kind of recommend you picturing how you solve it is by multiplying everything by the lowest common denominator. And I'll show you what that means in a second. So multiply each term, every term, by the lowest common denominator. Graphically, you're finding the x-intercepts or the roots, right? So when you solve it, you're finding x-intercepts or the roots. X equals, and then a certain number, right? Certain numbers. The reciprocal function, if it's a simple 1 on the top and you're doing a reciprocal function of, say, a linear or quadratic, then these ones do not have an answer. They get no answer here because of the horizontal asymptote. But if you have x's in the numerator, you may get answers in you may get answers, right? So some people go, how come this one doesn't get an answer? It's because it has a horizontal asymptote. The reason why is because it has a 1. Right? So this will create a horizontal asymptote. We know that a horizontal asymptote doesn't mean it doesn't pass through. So we know this. We know if we have a graph and we have a horizontal asymptote, there may still, so say I have a vertical here, there might still be roots. Look, right there, that's my root. And then maybe no root here, but maybe there was another root. But just because there's horizontal asymptote and behaviors doesn't mean there's no roots. Okay, so that's not what I'm saying here. But when it's a simple situation and it's a 1 on top, there's no way this will be happening, right? So with a 1 on top, we know what those are. That is like this sort of stuff, okay, basic stuff. And even if there's 2 asymptotes, the 1 on top means that there's no way I'm going to get anything passing through. Why is that? Because look, when you set this equal to 0, if there's a 1 on top, so if I go 0 equals 1 over whatever's down there, whatever x squared, x whatever, that goes up here and multiplies with the 0. And then you get 0 equals 1. Can I get any answers out of that? No. So what this statement here is saying that if it's a 1 on the top, right, if it's a number on the top with no x's, then there's going to be a horizontal asymptote, which also results in having no zeros, does not have any zeros. But just because something has a horizontal asymptote doesn't mean there's no zeros, right? So it's not the opposite. So this is not like an if and only if statement. If there's this, then there's this. But because there's a 1 on the top, right, just a number, any number at all, it's not going to have one because of the horizontal asymptote. But this is, remember we talked about if and if only if statements. This is not a backwards forward statement. So if it's a horizontal, it means it doesn't have 0. No, that's not true. But if it's this, then because of the horizontal asymptote, there was no solution, right? So they're just pointing out that because earlier in the chapter we did reciprocal functions, those were the ones with a number on the top, nothing else, just a number, no x. Okay, so those ones will not have an answer. Okay, and then the last point that I'm going to make here is that solving contextual problems, right, when there's a context or a situation, right, so solving contextual problems, you have to check for inadmissible solutions outside of the context, not just mathematically, right? So what I mean is we might get that x cannot equal 2, x from your restrictions mathematically, but if I'm making t-shirts, x has to equal, and the machine only makes 10 t-shirts at a time, I have to say, oh wait, because you're making t-shirts and the t-shirt only makes 10 t-shirts at a time, it has to be greater than 10. So the context is not always going to be the same. Each question is kind of you have to look at it and kind of read the context, so the context. Also, what some people do sometimes say is they say, it can't be negative, it should never be negative. That is not always true. We had in and again, I just did this with the grade 11 class, we had sometimes a revenue question. And we would say, okay, I'm selling 500 t-shirts, I'm losing 10 sales every time I sell them for $30, and I increase the price by $2, something like that. And we said, let X be the number of increases in price. Sometimes X would get me a negative number. X would equal a negative answer. And you'd be like, oh, you can't be negative. No, you can have a negative. If X is a negative, and I'm saying it's increasing by $2, what does a negative X mean? Yeah. Decreasing it by $2. So you can't just say, hey, based on every context question, I'm never going to look at a negative answer. No, that doesn't make sense. So not just negatives, it's the context. Okay, so don't say, oh, negatives. Also, every positive number might not work as well. So again, I just did this one with my grade 11s. We had one of those things, and we cut out the squares, right? And we folded it up, and we said, okay, we've got the little squares cut out like that, and we folded it up to make a little box, and we said, okay, cool, those are the squares we cut out. We got two answers, we got to an answer. So here I said, okay, something I think it was 20, and this was maybe 30 across. We got potentially two answers, x equals 2.7 or x equals 11.4. They're both positive numbers. Are they both possible answers? No. Which one's not possible? Because when you try to cut 11.4 out of two squares here, not possible, and then you're going to say why? Because it's too long for the side length, right? It becomes a negative side length. So just because they're positive doesn't mean they're answers. So that's what I mean by context, right? So the context of the question doesn't say just dump all negatives. It doesn't say take the bigger number, right, or the smaller number. You have to look at the context. If I'm telling you this is 20 and you're cutting out 11.4 squares, it's impossible to cut out 11.4 squares because I gave you a side length of 20. Okay, so look at the context. And we've been doing this already before, right? So we've done this before on questions. So you're still doing that same idea, is that look at the question and see if what you answered makes sense, okay, based on the context. That makes sense there? Sorry, question?
No, it's all good.
Okay, all right. So then now let's go ahead and solve this. Now, this first statement I said, by multiplying everything by the lowest common denominator. Now, you have simpler questions. These ones are simple because there's just one term on one term, right? So there's one term here and one term on this side. So a lot of people say, can I do cross multiplication? Yes, you can when it's a one term by one term. But cross multiplication, I'll show you what that means in a second. So cross multiplication is this. If I had x over 2 equals let's say 8 over 5, something like that. I would cross multiply. So we did this a lot in grade 10 trick. We do this. We cross multiply. So this base goes up here, and we go 5x equals 2 times 8, which would get me 16, something like that. What you should hopefully note is that the 2 needs to come up. The 5 could have stayed where it was. Like, you didn't have to cross it. You could just brought the 2 up, and then you start to go, oh, right. So actually, when you became, hopefully, started answering more of these, you go, hey, you know what? I don't need to fully cross multiply. I can just bring the 2 up, and then I've got my x isolated. So then the more the math you see, you kind of go, oh, I get it. Like, I can do this in a better way, right? So that's cross multiplication is straight doing that. Now, this cross multiplication works when you have two terms, one on each time. What if I had this? You can't I can't just bring the 2 over here and the 5. That doesn't make sense anymore because this is an extra term. So cross multiplication is only used in simple situations, and sometimes it's not useful because the more math you know, you kind of go, I don't need to cross both of them, I just bring the 2 up, right? So it's kind of a simplified way of looking at it. If there's more than one term, you cannot cross multiply because where do I bring the 5? I have to bring it to both. So what I'm saying is that when you look at this, you're actually saying, I'm going to multiply all of these by 10, which is the lowest common denominator, right? And you're saying, if I multiply that by 10, I would get the 5x. This would become a 30, and that 5 goes into that 2 times 8, 16, right? So you're actually multiplying by what's called the lowest common denominator. Right, so that's what you're picturing in your head. So it's not, cross multiplication only works in simple situation. It can be improved upon. And then here, when there's more than one term, you don't want to cross multiply. What you're doing is you're multiplying all of them by the same amount. And the same amount that we multiply them is the lowest common denominator. Okay. Someone also asked me first period if can I make these both over 2? and then do cross. Yes, you can. But then you're kind of adding more work to your life. I find this easier. Just say, all of them multiply by 10, and it's a little faster. But yes, if you want to, you can make these 1, make them both over 2, and then go back here and then do a cross multiplication. Okay, but that adds another step to your life, is that you're doing a lowest common and then doing cross multiplication, just to do cross multiplication. So what I recommend is that multiply all the terms. So think about it not in terms of just this, which is your simplified cross multiplication, but I'm multiplying all the terms by the lowest common. So for here, I know it's over 1, but I'm multiplying both sides by x minus 3. And then what happens is that this cancels out. You don't have to show me that. So if you're like, I don't want to show that, you don't have to, but that's essentially what you're doing. You're multiplying both sides by the same amount. That cancels out, and then you're left with x minus 2, 0 times that is still 0. Right? So in your head, you're thinking, I multiplied both of them by the lowest common. Why is this a little bit different? It's just because of the extra terms. Like, it'll work for any number of terms, not just 2. Right? So people, when they do cross multiplication, you can only do 2 terms. So this kind of thought process works for any number of terms. Okay. Also, what I need you to always do, and I will not always give you the hint, right? In fact, I won't, is state restrictions. As soon as you get anything with a denominator, you have to state restrictions. Okay? And again, we didn't do this before in chapter 3.4, because 3.4 was only polynomials. So chapter 5 is looking at rational, so there's denominators. So that's why we didn't do it before, because we didn't have x's in the denominator. So now we have x's in the denominator. Right away, you can state it at the beginning. As soon as it's factored form, I state it. So I go, comma, x should not equal 3. So then I've got it somewhere, right? You can have it at the beginning or at the end, but I've stated it, so I know it's there. Okay, you don't have to state it again at the end, but in my head, you're telling me that x cannot equal 3, so do state it. It might not be relevant to my answer, because look, x equals 2, and you're done anyway. But do a look back and go, okay, wait, is there a part of my restriction? No, we're good. So you stated it right away with the initial question, saying my initial question is restricted. I went ahead and solved, and I got my answer, and I'm good. Does that make sense? Any questions with that? Okay, so one more time. Right away you get the question. If you forget, then do it the next step. So do my restrictions. X cannot equal 4 or negative 2. All good? Go ahead and multiply. So yes, this is cross multiplication, right? So I want to show you, yes, it is. But what you're imagining is that you're multiplying both by the lowest common denominator. You don't have to show this, but I'm actually doing this to both sides, right? To both sides, x plus 2, x minus 4. So then this crosses off with this. That's why I'm only left with, that's why I'm only left with here, this one and this one. So that's why this one gets the x plus 2, x plus 3, right? Because that cancels, this one cancels with this one. And then here, the x plus 2 cancels with the x plus 2, and you're left with equals x minus 1, x minus 4. And no, you don't have to show this. This is just in your head, right? So you don't have to show me this. You can just show me this. But that's your thought process, is that it's because you're multiplying it by the lowest common, and then it cancels out the denominator there. You've already got it restricted, so I need to see the restriction. Okay, even if it's not relevant to your answer, it's relevant to the initial question. The initial question is already restricted. Right? So you say, from your question, I'm restricting it. I'm going to go ahead and solve it now. So then I get x squared plus 5x plus 6 equals x squared minus 5x plus 4. And then bring the x over. So that cancels with this one. And you're going to bring 10x equals, and I'll bring the 6 over, negative 2. X equals negative 2 over 10. So then it equals negative 1 over 5. The only time you can drop the left side is when there's a single letter like a formula left there. You can still do x equals. I've noticed that some people are dropping the 0. Okay, so you can't drop a 0. You can't go, oh yeah, there's no number there. Nothing in versus a 0 or different things. So the only time you can drop it, usually the only time I ever drop it is like with a formula. So area is length times width, 2 times x plus 4 equals, so it's a formula. Right, so one single letter, or the quadratic formula, so x equals negative b, da, 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 and then the next ones I put equals. So if it's a formula, okay? But don't drop a 0, okay? I noticed a few people are still doing that once in a while. Okay, so here I've got that, and then I already have my restriction, but it's not affected by my restriction, so I'm done. I've got this, I already restricted the question, and we're done. All right, so I just need to see it at the beginning. You don't have to restate it. Moving on. Up. Read this. Given the concentration C in the tank at T minutes, this is the equation, find when the concentration reaches 3.75 grams per liter. So this 3.75, this is going to go into the concentration, and we're going to solve it. Okay, so this question does have context, so we'll have to just make sure we think about that a little. And we're going to say, okay, so 3.75 equals, so 3.75, it's not a long question, so I'm just starting it right here. So 3.75 equals, and we're going to go 10t, 25 plus t. Okay. I'm not going to mark neatness, but try your best, because now you're in grade 12. Try to put that lined up. Okay, it should not be that it looks like 3.75 is only equaling the numerator or the denominator. Try to do it. I'm not going to measure it or something. It's just, but try to make it look clear. And again, it's not neatness, it's clarity, right? And again, when we get to other stuff, we have limits. You cannot write it at the top or the bottom. It has to be written in the middle. So you should be writing this in the middle, right? Again, grade 12, even actually my grade 9s as well. Okay, so yeah, so start to train early. Okay, so try to your best. It's not going to be measured, but try your best not to put it at the top and bottom. Okay, so this one here, we've got this. Again, this is a situation where cross multiplication will work because it's term by term. So you can just bring this one up and that one across. What you're imagining in your head is, yes, I'm multiplying both sides by 1, 25 plus t. So this one needs the 25 plus t. So this will be 3.75 times the 25 plus t. This one, the 1 comes up here, so it'll be 10t. So this is the case where, yes, cross multiplication is easy to picture. Okay, but once it becomes more terms, can't do that. Okay, and I'm just going to go ahead and solve. So bring that in. I got 93.75 plus 3.75t equals 10t. Oh, I forgot to do my restriction. So comma, t cannot equal negative 25. So always start with your restriction. If you start to solve, just stop yourself for a second, go, wait, restriction. Is that my only restriction, knowing that this is a context question? There's a context to it. What else do I have to think about? Yeah. Yes, exactly. T, so is that an and or is that an or statement? And it can't be negative, right? So at the same time, so and t has to be greater than or equal to 0. I'm thinking it can equal 0? Yeah, at the beginning of the, I'm thinking t minutes, right? We're doing an experiment of some sort. There, so this is an and scenario. So, yeah.
So what if our restriction was like t cannot equal 25, but t can equal 25? Like it does have a concentration at 25.
Then you would say it cannot. So because your initial question is, it excludes that. So that's why my initial setup of this problem is that t cannot equal 25. For some reason that data is gone, or the amount that we put in indicates that you can't use that, right? There would be some reason why it's in the denominator. As soon as it's in the denominator, it's a restriction, so there must be some reason in the context of the question that it doesn't work. Right, so yeah, so even if it, so if you say, oh, it equals, say it equals 25, like you said,
Yeah.
and you go, nope, cannot equal 25 because it's restricted.
Okay, so even if the context would make it seem like it can equal 25,
Yes.
you still have to write.
Still restricted, yeah, based on this first statement, so that's why. So do we want both of these? Yes, so exactly. From that first one, it's knocked out no matter what. So if it said t can equal 3, t can equal 3, even if it's your answer. You would say, based on the context of my initial question, it's not allowed to equal 3. Yeah. Right, so it's a done. This is a done statement from the get-go, yeah. Okay, so I want them both to be happening, right? So I want these both to be, I want it to be greater than 0 and not equal to negative 25, right? It's not an or situation. I want them both. So then I would say, so therefore what? Right, we did this before. So if I have two statements, is this redundant? If I'm saying this and this, what's my conclusion? Yeah, t is greater than or equal to 0. So yes, I want to see this, right? This is part of the idea that it's a word problem, so I'm going to see that you did this and then you did an analysis. Okay? If you skip this part, I would probably accept if you went t can equal negative 25, but therefore t has to be greater than or equal to 0 because I did the context here. Some people are like, but I wrote it twice because I was analyzing that this and this equals this. If you went this and then this, I would accept that because you're saying, but actually it can't be equal to, it has to be greater than 0 because that's not going to work anyway, right? I would have already knocked it off, okay? But I do want you to look, I want to see this for sure, and I want to see this, your conclusion, okay? I usually do both and then I conclude, but if I saw this and this would be okay, so I would accept it if you wrote this, but then concluded, right? So yes, writing it isn't bad, but at the minimum, I would be like, okay, I got this, and then you concluded this because of the context of the question time. Okay, let's go ahead and solve. I'll bring this over. So 93.75 equals, I got 6.25. I gave you guys a nice number, and it was 15. Okay, so then all of this is irrelevant, but based on the context of the question, I still want it. Okay, so based on the context, we still want this written there, even though, look, it's irrelevant to my answer. But we're analyzing the question first. Okay, and then my conclusion is going to be therefore, find when the concentration reaches. It reaches 3.75 grams, or 3.75 grams per liter at 15 minutes. Okay, so quick little sentence.